So this is going to be a tutorial on how to use the command line version of my Draconic Reactor Lewis script, meant for controlling Draconic reactors, preferably in the current mode at the maximum possible temperature without going over 8,000 degrees. The maximum possible safe temperature, I should say. Note that this program is not incomplete, and at some point in the future I hope to have it fully kitted out with a UI along with a bunch of other features that right now I can't implement, but still would like to have the functionality available to people who want to be able to fire up their reactor and only ever have to worry about refueling it. So this tutorial is going to assume that you already know the basics of OpenComputers in terms of getting a computer set up, connecting it to a screen, and connecting the computer to different peripherals, such as adapters, through the use of adapters mostly. And this is going to assume that you've got OpenOS installed, and essentially all the basic things that you should be able to get from watching basically episode 1 of any OpenComputers tutorial. So the reactor script can be called whatever you want it to be as long as you remember the name of it. And you can save it anywhere you want so long as you know how to navigate there using the commands cd and ls and whatnot. So I have this saved in my home directory as reactortest.lua. So we're going to open that up really quick because you're going to have to change some settings if you want to get this to work on your reactor. Now, most of this you're not going to need to look at. The main three things you're going to need to look at are this output flux, input flux, and down here this reactor output multiplier. These are the only three things you're going to have to interact with in this program. So if any of you out there are allergic to programming or even looking at programming language, don't get too worried about the specifics of all this. Just know that you only have to touch this, this, and this. So what we're going to need to keep track of is the addresses that our computer recognizes, uses to recognize our input and output flux gates. That's these guys right here. So what we're going to need to do that is obviously adapters. These are how OpenComputers connects and interacts with any blocks outside of its own mod. So we're going to need to place these down and connect them to your computer of choice using network cable. It does not have to be connected to the computer as long as it connects to a peripheral that is connected to the computer. So you're going to need 2 to 3 adapters, or as many adapters as you need, as long as you are connecting your computer using the adapters to both your output flux gate, your input flux gate, and either one of the 4 stabilizers or your energy injector. The energy injector and the stabilizer adapter is how the computer will actually communicate with the reactor itself to give it commands to charge, turn off, and turn on, and whatnot, say when the reactor is low on fuel, and how it will monitor the reactor's temperature, field strength, and whatnot. The 2 adapters connected to the flux gates will be used by the computer to actually set the output and input values to keep the reactor under control, essentially. So if this program is running, which we will later in the video, you will notice these numbers constantly changing as the program changes the inputs every tick, so basically 20 times a second. So you're going to need the addresses of just your flux gates. The program is capable of just automatically gaining the address of the reactor, so you don't have to worry about attaining the address of that. But if we scroll over here to OpenComputers and scroll down until we find the analyzer, this is what you're going to want to take. And using it, you're going to want to shift-click on the adapter connected to the device you want to measure. So in this case, we want to find out the address of this flux gate, so we shift right-click with the analyzer on the adapter connected to it, and you'll see that it gives us this handy little address string. And it even has this handy ability where I can just click it, and it'll copy it to my clipboard. Then, since that is the flux gate coming out of the reactor, you'll see it's connected to the stabilizer pointing into this energy pylon connected to this Draconic energy core. This is my output. So I'm going to go over here, find my output flux, and you'll see that this is creating a component for the computer to use, and this is the address string. So this is from an old test rig, so this is not a valid address, so I'm going to want to close this. Make sure you keep the quotes intact, and you're going to want to, by default, middle click is what OpenComputers uses as its paste button. Now we're going to go through the same process on our input flux gate. So just shift right click on the adapter connected to your input flux gate to gain the address for that. Once again, open your chat, click the string to copy it to your clipboard, backspace this out, and middle click to paste. Now keep in mind that if any circumstances were to arise, say you to remove your reactor or any other factors that result in one of these flux gates being destroyed or broken in general, and then being replaced and connected to an adapter, it will be given a new address and you will have to re-enter it into the program. Also, if we break the adapter, that may or may not cause things to change. So if I replace the adapter, shift right click, that is a B727. Yes, so breaking the adapter or the flux gate, that is the wrong way. Okay, I was mistaken. I apologize. Breaking the adapter connected to this flux gate will cause its address to change, but breaking it and replacing it, as long as you place it in the same orientation and keep it on the same spot, shouldn't change its address. So now that I have done that, I am going to need to find its address again, B727, and since it has changed, I am going to have to reset it here under my output flux gate. Remember, middle click to paste and save. So now the last value for us to adjust here is the reactor output multiplier. Now this is a variable used by Draconic Evolution that can be edited by mod makers for balance purposes to make the Draconic Reactor output more energy than its base amount. So by default, if you just download this in a vanilla mod pack, or you create your own mod pack, or you just download this mod standalone, this will have a default value of 1. And it may be different for you. If you want to find out for yourself what it is, go to your pause menu, go to mod options, search for Draconic Evolution, there it is. Click on it, click on config, go to the tweaks tab, the third one down, and scroll down. These are all in alphabetical order, so it shouldn't be too hard to find your reactor output multiplier right here, underneath your fuel usage multiplier and a few other variables. And you'll see that in this case, it is 1, as I am playing a custom mod pack that I made myself and I have not changed any settings. That makes sense. So I have changed my reactor output multiplier to 1 to reflect this. Hit Control S to save, Control W to close down the program, and everything should be calibrated should you have done this correctly. Now, I do advise, if you are using this program for the very first time, just to test this on a reactor in creative mode to make sure that there are no issues and so that you can practice getting an OpenComputers setup going. But once you are ready to run the reactor program, make sure that you are in the directory in which your program is installed. Mine is in the root directory, or the / directory, so I am in the right place. So now it should just be a matter of typing reactor test. You can tab to autocomplete if you want to. And this program accepts 2 arguments, or basically 2 parameters, and that is 1, the temperature you want the reactor to essentially hold at, which for most people who want to get the most out of their reactor is probably going to be 8,000 degrees, because that's right before the red line that starts leading into some inefficiencies and higher fuel consumption and an exponential increase in field strength and just a whole bunch of nasty stuff that we really don't want to deal with. So the default is usually going to be 8,000. And the second parameter is the shield strength we want the reactor to hold at. So essentially how much wiggle room we want the reactor to have in terms of shield strength. By default, you do not have to enter these 2 values. You could just type in reactor test and hit enter to start the program, and it will select default values. But if you want to input custom values, like say you want the reactor to run at, say, 10,000 degrees because you're some kind of madman, and in an even more mad fashion, you only want to run it at, say, 10% shield strength, you could do that. Also, I should note that the first argument for the temperature is just in degrees, so 10,000, we'll try to hold it at 10,000 degrees Celsius. But the shield strength argument here, the second one, is based on a percentage scale from 0 to 1. So 1 would be 100% shield strength, and 0 would be obviously 0% shield strength. And the default for the reactor program, should you enter no arguments, would be 8,000 degrees and 50% shield strength. So if you don't enter either of these numbers and you just hit enter, the reactor will attempt to hold at 8,000 degrees 50%. So I'm going to go ahead and hit enter, and it is going to give a bunch of stats. These are mostly for debugging purposes, but feel free to look at them and try to decipher what they mean. The code for Draconic Evolution itself is up on the GitHub for the mod author if you want to visit, try to find the source code for the reactor and try to decipher what all these terms mean. But basically, these are all the stats that the program will update in real time, showing how it's balancing the reactor. So most of these are just in-between variables for the calculations, but right here you'll see it's finding the saturation it needs to make sure that the temperature has 0 rise at its target temperature, which is basically, this is the saturation the reactor needs to be held at in order to hold the temperature still at 8,000 degrees, which is our current target temperature. And right below that is how far away our current saturation is from that target, which obviously it's incredibly high, because if we look at our reactor, I just ran it recently, and so it's built up a bunch of energy in its saturation bar. That's why the error is so high, because saturation's all the way up here, and it needs to be somewhere down here at around 11%. The second section is for our shield calculations, so basically what our temperature drain is, or our temp drain factor, which only really comes into play when we're running the reactor above 8,000 degrees. Most of the time when you're running the reactor in normal operating range, which is 2,500 to 8,000, this is going to be 1. This is our current field drain. This is just an in-between variable that the mod uses to make the reactor behave the way it does. And once again, this is the error between what our shield strength currently is and what we want it to be. So I am going to start the reactor, and when I do, we're going to see that, well, first let's zero out our flux gates, just so that you can actually see the program do its work. It might actually already be doing it if I try to save this. Yes, it is. I think it is overriding me. I believe it is currently trying to flood the reactor. If we hit charge, you'll see that instantly the field strength was shot up to 50%. It didn't have to charge the saturation at all, since we already have over 50%, and the core temperature hit 2,000. And you'll notice that now it has detected that the reactor is charging, so it's flooding the reactor. That's what it was doing by setting the, yeah, see, it set the input flux gate to 5 million RF per tick. It was 500,000 before. And now, assuming I am working with the correct version of this program and not a scratch version, that would be rather embarrassing. When I hit this button, see, make sure that our target temperature is 8,000, and I believe I entered this with no arguments, so it should be trying to hold the field strength at 50%, which, yes, you'll notice that since our error between, essentially what this error is the difference between our current field strength and our target strength. You'll notice that it's 0, which is correct, because we're wanting to hold at 50% and we are at 50%, so there's no error. So I know that it's trying to hold at the right temperature, because it lists the target temperature right here, 8,000 degrees, and our field strength error is consistent. I can go ahead and hit activate, and nothing should blow up if I've set up all these variables right. Look at that, stops the energy saturation right at about 11.4, which if you were paying attention is where it was showing. And it will slow down quite a bit, but you'll notice that it should just park the temperature right at 8,000. It does take a little while. Might be a bit of an error in the calculations. It was running a bit better before, but it seems that there are still a couple calculation errors. Nothing too major. Something to work out. But this wasn't meant to be a total demonstration of the program working perfectly, but just showing that it can function while getting your reactor to basically the temperature it needs to be without, you know, blowing up your reactor, which I think is what most people probably want out of their Draconic control program. They don't really care to get it to exactly to these flux gates, you'll see that these values are changing rather rapidly as the control program attempts to regulate the reactor. It is changing the input of these flux gates once every tick, so that's 20 times a second that it's changing this to make sure that it behaves itself. And you'll notice that our field strength is holding almost perfectly at 50%. That is the main thing to pay attention to out of this reactor, is not that you're getting exactly 8,000 degrees, although that would be very desirable, and earlier demonstrations of my program that you can find on my channel that were uploaded maybe a month ago or so, were able to reach this perfect temperature. The main thing is that you're able to keep your reactor shield exactly where you want it to be, which is what this can do. And great thing about reactors being run this stable is that if you get a reactor into a stable state, which is basically to say you find an input and an output value that works, assuming you don't change those values, like I could literally just terminate this program by hitting Control-Alt-C to terminate the program, and you'll see it's no longer running. These flux gate values are no longer changing, and you might think that, oh, that might be really bad, but if you'll notice, our containment field strength is actually going up. And you'll notice that, you might not notice it straight away, but our core temperature is very slowly going down. That's because as the fuel in the reactor is consumed ever so slowly, this causes the reactor to generate more energy at the same saturation level. So this generation rate will slowly start to climb up, which will slowly start to fill the reactor faster than this output can drain it. So that's why our saturation is slowly starting to climb, and as the saturation rises, the temperature will naturally start to fall. That is the link between these two, is that the temperature of the reactor is, or at least the change in temperature of the reactor is directly determined by how much saturation is in the reactor. So as a rule of thumb, the higher the saturation is, the lower your temperature is going to be. So this is slowly going to rise, which means that I can literally just terminate this program while the reactor is running, and assuming that it wasn't in a fail state before, like as long as this shield wasn't being drained by like 5% per second and it was holding steady and the temperature was holding steady, I could just terminate this program while it's running and then enter target temp, or sorry, not target temp, reactor test, jeez, and enter in a different target temperature. Like say I only want to hold it at 6,000 degrees to keep it a bit cooler, but I only want, say, 1/4 of the shield strength. I can hit enter on that, and you'll see that it is slowly starting to put that into action. Containment field is going to start dropping, because obviously since the shield strength is higher than where we want it to be, the flux gate was actually being set to a negative value, but obviously you can't suck energy out of the containment field, so it can only wait. That's essentially the same as having a 0 input, so it was just kind of letting the containment field fall to its new desired strength, and you'll notice that our saturation is now around 26%, and the reactor is holding somewhere very close to 6,000. I'll have to do a little bit more finagling to get the program back to where it was before, so that it can hold right at that 6,000 mark. So hopefully this was helpful. Hopefully I didn't ramble too much and get caught off track too much in this tutorial. So in this I went over how to connect up the flux gates on your reactor. This tutorial also assumes that you know how to set up a Draconic reactor properly in terms of the spacing of the stabilizers, having your flux gates oriented the right way, and making sure you have the proper cables. You do not know how many times I have talked to people who have asked me, why isn't my Draconic reactor working? I've connected everything up to it. I try to get the input. I try to input energy into it, but the containment field just tanks down to 0. Odds are 9 times out of 10, or at least 8 times out of 10, these people are using conduits that cannot support the amount of energy transfer needed. This reactor is running at basically 0% fuel conversion, which means that this is about 1/3 of what it's going to be generating toward the end of its lifetime when you reach a fuel conversion level of, say, 60 to 70%, when you're going to be outputting easily 2 to 2.5 times as much energy. So this field input rate, right now it's still pretty high at around 135,000 RF per tick. Like, if we take a look mechanism's ultimate universal cable, that can only support 128,000 RF per tick. So already, even at the low end of what a default Draconic reactor can produce, we're already above that threshold. So this already wouldn't even be able to support a quarter of the containment field strength, not even running at maximum temperature. Be sure to use something that can support, if not multiple millions of RF per tick, just go for something that can transfer an infinite amount of RF per tick. It will save you so much headache and keep your reactor from blowing up. Just a little tip there. Just use infinite RF transfer. If you're at the stage of the game where you can afford a Draconic reactor, you can afford a few cryo-stabilized flux ducts or something similar. You will save yourself a lot of time and a lot of Draconic reactor craters. So hopefully this has been helpful for you. And if you have any questions, there is Draconic Evolution does have a Discord that you can find on the GitHub, I'm pretty sure, and a few other places. And I am an active member there. So if you have any questions, I am fairly active there, at least at the time of recording this video. So just drop some questions there if you have anything. There's a lot of other people there that are more than willing to help as well. So I hope you found this useful, and I'll see you guys in the next video if I ever make one.